All right, so here we are. We're about to start a couple of lessons on learning how to factor. And factoring is a huge part in mathematics as far as it giving us another tool to help us solve equations, specifically equations that have powers bigger than 1. So you don't use factoring whenever you have a linear equation, but whenever you have quadratics and cubics and things like that, then factoring is one of the things that we'll be able to use to help us solve them. So this lesson's called factoring, and it's not really in the book, and that's why your assignment is just this worksheet. And so here we go. We got 3 objectives. We're going to first factor polynomials by taking out the GCF. This will always be the first step whenever you factor. And then we're going to do 2 different kinds of factoring after that. We're going to factor some binomials, number 2, and we're going to learn how to factor by grouping. Okay? So let's start off with a couple of warm-up questions. So here we go. First warm-up question. Which of the following numbers, look at all those numbers there, which of them does not belong? You might want to just pause it for a second and just take a look at those numbers and decide which one of those, it doesn't belong in that group. So here you go. The number that doesn't belong in the group is the number 10. The reason why is because every single other number that is up there, those are all prime numbers. And remember, what prime number means is that the only thing that divides that number evenly is 1 and itself, the smallest prime number being 2. 2 being the only even prime number as well, because any other even number, 2 would go into it. Okay? So 10 is not a prime number because 10 is 2 times 5. It's called a composite number. Okay, so here's the next warm-up question. I want you to factor 45 as the product of prime numbers. So you're starting with the number 45 and then break it down to all of its prime factorization. That's what we call it. If you're kind of stuck here, think about factor trees. That's the kind of thing that we're talking about. So go ahead and pause, take a second, factor that number out. Okay, so here we go. So we'd start with 45, and I'd pick 2 things that multiply up to 45, and it could be anything. So for example, I chose 5 and 9. Okay, so 5 is a prime number. You don't do anything with it. 9 is not, because 9 is 3 times 3, so you break it up again. So that was called the factor tree. You might remember doing that way back when, and they help you break a number down into its prime factors. Okay, take any composite number, break it down into its prime factors, and that's what you're doing whenever you are factoring a number. You're trying to break it down as a product of primes. Okay, so this 45 can be written as 5 times 3 times 3, or sometimes written as 5 times 3 squared. Those are its prime factors. A long time ago, there was this guy named Euclid. Maybe you've heard of him. He came up with this theorem. It's called the fundamental theorem of arithmetic, that says, hey, whenever you go to factor a number, a composite number, and get its prime numbers, there's only one way you can do it. As in, everybody, whenever they factor, say, the number 45, it will always be 5 times 3 times 3. Those are the only prime numbers that you can factor that into. Okay, so that's kind of interesting. He did that thousands of years ago. Okay, so, I mean, we're not really factoring numbers, but the things, the terminology, and the concept is the same whenever we're talking about factoring polynomials. Okay. So when we factor polynomials, it's analogous to factoring numbers, but we don't use the trees. Okay, so what I'm looking at down there is a quadratic, and we can factor that quadratic. It's x squared plus 7x plus 12. And what you're trying to do whenever you factor this is you want to write it as the product of prime polynomials, not prime numbers, but prime polynomials. Okay. So, for example, this one, we may not know how to factor this just yet. Don't worry. By the end of all these lessons, we will. The way that I factor this is x plus 3 and x plus 4. Those 2 taken individually are prime factors. You can't break those down anymore. And that's our goal whenever we go to factor polynomials. Okay, so here, one exercise to conclude this video And it's kind of a review of something that we did in the division lesson. So, whoops. Given that x minus 4 is a factor of this cubic polynomial, we want to rewrite that cubic polynomial as a product of two polynomials. In other words, what we're going to end up doing is factoring. Okay, so if x minus 4 is a factor of this cubic polynomial, that means it divides it evenly. Its remainder is going to be a 0. Okay, so this is of the form that I could use synthetic division on, so that's what I'm going to go ahead and do. So 4 on the outside, and then across the top, it doesn't look like I'm missing anything, so a 1, a negative 6, a 5, and a 12. Bring down the 1, multiply by 4, negative 2 by adding them. Multiply by 4, negative 8, negative 3 when I add it, times the 4 is negative 12. I get a remainder of 0. So this, the answer, the quotient, is x squared minus 2x minus 3. So if I were to multiply that times what I divided by, which in this case is x minus 4, I have just written this cubic polynomial as a product of two polynomials. Now, what I'm trying to do ultimately, though, is take a look at these and say, are these both prime? This one is prime. You can't break it down anymore. But the second one, it's not. I can break it down further, and so I would keep going. So it's kind of like whenever we factored 45, and I broke it down into 5 and 9. Like 5, it was prime, but the 9 you could keep going on. And that's what you have to check. And we will see that I could rewrite this, or I can keep factoring it as x minus 3 and then x plus 1. Okay, don't worry right now if you do not understand where those other two factors came from. You will by the end of all of this factoring stuff. All right, something to look forward to.